In this recording, I will talk about three tools for the evaluation or testing of expressions or conditions during compile time so that a safer or efficient program can be created for the runtime for the execution. The tools I will talk about are constant expression, constexpr, constant evaluation, consteval, and static assert. Static assert is for making sure that a condition is satisfied during compilation. If compiler finds that the specified condition does not satisfy, then it will raise an error. Compilation will not be successful. Now let us do some coding for static assert. Static assert syntax is as follows. Uh, it receives two things. First argument is condition, and the second argument is the error message. If the condition is not satisfied, then static assert will actually send out error message. Compiler will actually use that error message in its complaint. So suppose I want to create an array int my array, and the size of the array, I want to use a variable which is defined here constant int n equals to, let's say, 100, let's say 85, and I use n. But my application suppose requires n to be in the range. Smallest value of n could be 1, range 1 and to 100 inclusive. That means the maximum value of n can be 100, the smallest value can be 1. If I do compilation of this code the way it is, it will compile, and I don't have any issue with this. This is just a warning which says that the array that was defined is not used. Now if by mistake or intentionally it happens that this happens to 185 in the code, this kind of mistakes can happen, very frequently. So in that case, I don't want I want to prevent this code from compiling. I want to make sure that when this code is compiled, then the value of n is in the desired range. So if I do compile with this, compiler will accept without problem, like in this case. So it's not complaining, is not complaining about the value of n. Now if I want to make sure that compiler actually does check that, make sure that this n is the value of n is not beyond the range. In that case, I can use static assert, and I could put the condition which will actually make sure that this n is in the range 1 and 100. So n is less than or equal to 100, and n is greater than or equal to 1. And if this condition is not satisfied, I want to display our error message. Array size must be in the range 1 to 100 inclusive. So if I put this static assert statement here, then compiler will actually make sure that that condition has to be satisfied. Compiler will not pass this code through its compilation. So it is already complaining with the message the array size must be in this range, because this condition was not satisfied. And then if you see this kind of message, a programmer sees this kind of message, and the programmer can quickly go look into the code and try to make sure that this n is within the acceptable range, and the range here would be 85 or any number uh, less than or equal to 100 and greater than 1. And after this correction, then assertion this tool will actually evaluate this expression. If it is true, then it will just ignore everything, just continue with the next line. If this expression evaluates false, then it will actually complain and display this error message. Now this static assert can have many uses. One example of the uses I want to talk here is, suppose I have a template function which actually adds two numbers and returns the summation. And you can use this function with different data types of data. Integer int xi equals to 5, yi equals to 10, and zi maybe the expression where we want to store the value computed by the function. Double xd equals to 2.2, yd equals to 3.3, and zd. And I also want to use a string xs equals to, let's say, him, ys, zs, and character xc equals to, let's say, a, yc equals to b, and zc. Now let us use that function zi equals to sum xi yi, zd equals to sum xd yd, and zs equals to sum xs ys, and zc equals to sum xc yc. And we can also have CORT statement to display this data. zd and zs So in this case, if I let me try to compile this code and make sure it works. So it is working. It is displaying the summation of two integer values, summation of the double type values, summation of a string him and plus li Himalaya, and the summation of two character values. So if you look into this character values value, it I mean doesn't appear to make sense here. So a value, the underlying integer value a and underlying integer value b added, and the whatever was the result, corresponding character was actually displayed. In this case, if I want this function not to be used for for example, let's begin with I want this function to be used only integer and double type. In that case, what I can do is I want to make sure that the static assert actually checks the type is either integer and double, right? So you can do as follows. Here you put condition. The condition here would be, we are using one tool which is a tool to compare the two types, whether t is equals to one type or not, or is same as desired type or not, is same value t int, and we also want to allow integer and double type to be used. So or right. So if condition is not satisfied, we want to display the message double. So in this case, if I try to compile this with these two lines will actually um, complain, will be the reason for this static assertion to fail. So let us go and try to see in its execution or compilation basically. So compilation is complaining this it is the type must be either integer and double is the error message we get here, and complaining in line number 26. I think the original line that is causing is 26, and then within the function I think it's line number 7. So let's go back to the code. So line and 7, this is actually displaying the message, but the line which is causing is this line, right? So let me comment this out and try to run again. It's again complaining. Now it is in line number 25. So that std string, use of std string is also um, creating a problem here. So comment this out. Now there's no complaint, and we run, it is working. Okay, back to the code. For example, in this case we are actually only allowing two types. If for example, if I want to allow all the types except a selected type, for example in this case I want to not allow only character type and all the others type, actually I want to be allowed to be used to call this function. So for that let me comment this out, copy, and then I'm commenting this and pasting, try to make changes. So if I want to not allow only character, type must not be, should be character, and here we want to see whether this is the same as character, and if it is not, then this should be the error, right? So this should be the way you put static assert. So we have used all the types. We have used the function with integer, double, string, and character. So at this point this statement or this function invocation should be source of the problem. So it is complaining in line 28. We go back to the code and comment that line. It's not complaining. right? We can see the output here. And one thing I want you to take note is this this tool. It is usable only with the 17 standard. If you use I mean previous standard, for example C++ 14 standard, I mean compiler, 11 standard compiler, this tool is not available there. So if in this case if I compile using, let's say I'm using 17 standard, if I compile using 14 standard, and it will complain that tool is not available. So this is not available. And also if I compile using 11 standard, obviously that should not be available there. Const expr is a keyword that was introduced in C 2011 standard of C++. It is a tool for compile time evaluation. It is for evaluating an expression or function by the compiler during compile time. It actually asks the compiler, C++ compiler, to consider an expression, a variable, or a function as a runtime constant expression. Runtime constant expression means that the expression will be evaluated by compiler, and it will be set as a constant to be used by the program when it would be running. Const eval is similar to const expression, const expr, but instead of suggesting or asking compiler, it requires the compiler to make sure that the expression is evaluated by the compiler. In the case of const expr, compiler may decide not to consider as a constant expression depending on the nature of the expression or function. But when we use const eval, then compiler will not consider not using evaluating as a constant expression. Compiler must consider evaluating as a constant expression. If it is not possible, then compiler will complain during the compilation time. I am beginning with this code to talk constant expr, const expr. First, let me explain this code. In this code, I have used this structure array, which is a templated form of array. So it actually manages an array, regular array, but in template library. You can use this library to use this. This is a class, this class, and you want to use this class for integer type, and the 30 is going to be the size of the integer. You create object and you can initialize this to this data. We can use this. We have 30. The size is 30, so we can use the size here instead of 30, or you can use 30. So these are the values that I have manually computed to display our desired shape, or to plot on the console in the terminal. I actually want to display a desired shape that I'm going to be showing in a while. Then I pass this array into this function called print circle. This is the type of that object, received as a non-modifiable and reference type. This function uses this for each algorithm. This is called something called STL algorithm. I'm not going to be talking about this. Probably in the one of the future recording, I will talk about this STL algorithm in detail. But at this point, I'm just using it. And I mean, to use this STL algorithm, you actually need to include this library. And what it does is it begins from the first element of this array, and it continues to the last element, and it actually does this operation. So this is the entire operation defined in something called lambda expression. So I will also talk about lambda expression in one of the future recordings. I'm not explaining in detail, but just what is happening. It actually will receive that each element here, and it will actually iterate in a loop and display that number of spaces, and after that it will actually display asterisks for each element. It will do those things. So this logic actually, what it does is actually it displays this asterisk in this kind of circular. It intended to be circular, but it's not perfectly circular. It displayed in a certain shape, right? So let me run this program and see what output it produces. Then we will continue from there. So the compile and run. So if we run, it is actually displaying this asterisk in this format because of the data that is data carried by the array that I just discussed, right? So this is the output of the code we have, and these are the actually values that actually make sure that the asterisks that are displayed are actually placed in a proper position to create that kind of shape. Now if we know that this is the value which is going to be fixed, we can ensure that we can ask the compiler to consider this as a fixed value by putting constexpr keyword in this place. In this case, uh, this object is to be evaluated during compile time, so that it will be treated by the runtime as a constant value. That means in this case it is straightforward. So we have provided value, so it's there is no evaluation. It will just consider this these values as a the values that are actually stored in a constant expression type array, right? Now if we want to see why this is actually useful, sometimes this uh, manual computation of this values can be uh, complicated, can be troublesome. You may require to apply a lot of effort. So you can use the logic or algorithms or equations to compute these values. So to do that, we can put this equation to compute these values in a function, in an expression. For example, I can have a function called, let's say, create circular points, and in this circular point I want to supply radius and the center where we want the center to be, and how many number of points I want to compute. In this case it's going to be 30, right? So I want this function to be able to accept any value. So let me call this num. So you need to give type to this. Let me call this rad for radius. Let me keep it non-constant at this point, and number, sorry, int, and I want to return this array, I mean an object of this type. That means I would be returning this type object which contains the numbers, and which can be set to be to the object like this. So first let us create that array to be returned, and initialize default installation. Then I want to actually iterate int I equals to 0, I less than, let's say 2, I plus plus. Actually what I will be doing is, let me just copy that output from the terminal here. So this is the output that I just showed you just before, and this is a thing. I think it was something like this. And what I want to do is, actually I want to store this number representing this number of space. You have to insert first in one element, and in next element I want to actually store this number of spaces, so that once you insert asterisk, then it will insert that number of spaces and asterisks next time. Then control will go to the new line, and again it will store that many number of spaces followed by the asterisk. So the first element, or I mean the element with even numbers, will actually carry this spaces, this number of spaces in these places, and odd indices elements of this array will carry these spaces. So that is how I'm going to be creating this array. So for that maybe let me have another variable int j equals to 0, and my array first element is going to be center. Center will be I mean some place somewhere here. This is assumed to be a center, minus, and you're going to have a radius connecting this to the center, and you actually project that radius to this horizontal line, so that will give you this number of points, I mean spaces here. So it's going to be we want to have a pi data, so let me define, because we have cos pi cos theta, I mean radius cos theta is the projection. So pi equals to 3.14159. so we use pi divided by 2 minus because if you look into the cos feature of the cos, pi by 2 will be actually 0. So we want to, I mean we want to use pi by 2 as a reference, right? And then minus pi by, this is for, I mean this will actually see divide into this number of, I mean this spacing. So entire pi would be pi by 2. This pi by 2 is pi is actually 180 degree starting from this point to this point. If you see this center as a reference, and it is 180 degree, and then if you divide by size, that will give you the number of elements, that means the spacing, right? So by size times some value for adjusting the heights of the lines in which these are displayed, right? So these are the one line, two line, so I plus 0.5. I'm using this through some kind of hit and trial or some approach. And also I want to do some scaling factor here, 1.2, and then I actually floor it. Right, this is the expression to compute the first this many elements, number of spaces you will insert here before inserting this asterisk, and then after that in the next element this number will go there. So my array j plus 1 equals to center plus, first we compute this entire thing, entire spaces, then we'll subtract this many spaces from that entire computed spaces. So center plus 1.2 times rad cos pi by 2 minus pi by size times 2.0 times 1I plus 0.5. So then after that I do subtraction, j plus 1 minus equals to my a j. Then I have to increment j 2 times because I have already used the current value of j and the next value, so I need to increase j plus plus, j plus plus, and finally I will return this my array. So this will actually create this array, this elements, and an array with these elements, and with this I think yeah, with this I can actually let me comment this out, and let me create array call this my array2 and equals to I want to call that this function actually, call this function and set to this object to the object returned by that function. So and it actually receives, this function receives I think the radius, center, so radius, center and number. Right, so I need to define those radius and numbers. So let me define it, have macro definition, define 28.0. maybe let me make it constant, double radius, and then center, let me make it as 45, and size should be integer, int size, and double pi. I need to put a semicolon here. So these are the things we need. We will be passing this radius, center and size in the function invocation. So we have this array we obtained by calling this function, by computing I mean through the computation, and we can call print circle my ARR2. So let us try to run this. In the previous case it was hard coded values. In the second case it is more flexible, computed using the logic. This is more convenient approach than and finding out the data of hard coded values and then using it. If you are to use only fixed value for many times, for large number of times, then this kind of approach would be more effective. But if these values are not so much fixed, they can keep changing, then using this algorithm, I mean the function I mean computing through this function would be more effective. I'm compiling again. I got some errors here. Let me begin. So inside, I think I should have used equals to there. Quickly fix it. Size equals to 30. And what was another error? I think that and yeah, and other error is this use of cost, right? So maybe this cost function, this floor function is not available directly, so I need to include library to use these functions, and the library I want to use is, I guess, uh, C math library. Right. Let me go to the terminal one more time. No, still we have error. Size is not usable in the constant expression. So now we have I think we might have used a constant expression somewhere. Yeah, I think yeah, probably this is complaining, right? So we have used size here, and this is a constant expression, but let me just remove this thing here for the moment. Whatever variables you use with this constant expression, all needs to be constant. And line number 11. Okay, the problem here is that for example, if you have, let's say, if I create an array, a regular array, int 3 and use size, so it will obviously complain in this place, because this size has to be a constant. Similarly, if you use this size in this array, it has to be constant. So we need to make that size constant to overcome this issue. So constant, and try to see whether that solves the problem or not. So now I think the problem is largely gone. I think we should have used asterisk. I think there's a typo issue here. Go back to the code and should be asterisk. And another problem, let me try with this. Next problem is that was not declared in this scope. Maybe, yeah, maybe there was a typo in writing the function name. Create circular points. So create circular points. Okay. So now it is working. Let me execute. So now it is displaying the thing, but it was the values that were computed in the array was actually computed by calling the function and by executing the formulas and expressions inside the function. Now in this case, uh, when we want to actually create array like this, but this array is going to be used as a fixed array afterwards, then it makes sense to treat this as a constant expression, so that the runtime will not have to call this function. You want to ask the compiler to do all the computation of getting these values, and so that runtime will have efficient the resulting application will be more efficient. It will take less computation. To do that, you can tell the compiler that I want you to consider this object as a constant expression by putting this keyword const expr. So compiler will try to see this as a constant expression, but one thing is that whatever is involved in this constant expression has to be constant expression. For example, in this constant expression, you call this function has to be constant expression. So if I call with this, I will surely get a problem. So it is complaining that call to non-constant expression function for a constant expression, right? So we can go back, and you have to make sure that this function is declared as constant expression by putting this keyword. And in this constant expression, all the values that are used has to be constant, right? So you need to turn this to constant, and you can also make this constant. So let us try again with this. So radius is not usable. It is in line 77, 6. So we have this radius is used, and which should be constant. Oh, I think yeah, there's one. You need to make this constant expression. Because we are using this in the function invocation, which is a constant expression here. So we are using in this place, so you need to make that constant expression. Let me try again. So now it is running. Right, so now we are actually asking compiler to treat this as a constant expression. Compiler may treat, may not treat. It depends on whether compiler determines, but in this case most probably it was treated as a constant expression. And if you want to see whether it was treated as a constant expression or not, we can use again the static assert I discussed in the beginning of this video. And you want to make sure that this is a constant, make this constant expression, and try to compare this value. You do manually compute one value and try to see whether compiler can find that value. If a compiler determines computes the value for this array, then compiler will be able to pick that value and compare with this value, right? So that means at this point, before the execution of static assert, each compiler should have already computed. That means the compiler actually has considered this as a constant expression. So we want to do this comparison here. My ARR0 equals to my ARR2 0, and the message is not at not evaluated at compile time. So if this message is not displayed, and then it is going to be this was actually treated as a constant expression by the compiler. So no complaint, that means it was constant expression. Now let us go ahead and talk about constant evaluation, const eval. So you can ask the compiler to make sure that it is evaluated. For example, if I have let's say cout statement, right? So if I have cout statement to display something here, my j, this is this is a cout statement that compiler cannot execute at compile time. It has to be executed by the runtime. So therefore compiler actually will not treat this function because of the presence of this cout statement. Compiler will not treat this as a constant expression. So then if I do compile this thing, so we have a problem, right? So this is this was not evaluated. And if I go back and let's say remove this static assert, we go back to the coding and maybe remove this thing. And try to compile one more time. So it is compiling, right? Uh, but definitely this the data was displayed. That means it was not the function was not evaluated at compile time. It was actually left for the runtime to for the function to be invoked or called. So in this case, if you want to actually force, you want to make sure that this function is I mean this is unintentionally you can set this object to this function output of the function, and then if this may not be intentional, I mean unintentional or by mistake, you actually did mistake putting this constant expression, then if you intend that this function has to be evaluated at compile time, then you can force the compiler by putting constant evaluation here, const eval, and it will actually require this function to be evaluatable, or it has a feature that so that it can be evaluated at compile time. So at this point with this change, if I compile, it will not compile, it will complain. So it will require the programmer to make changes so that there is no problem, right? So it is complaining. This is so I think this current error is because this constant evaluation was introduced in 2020 standard C++. In 17 it was not available, so you can change standard to 20. So now we are getting the real error. This cout statement is actually causing problem. You go back to the code and comment that out. This statement, and if you do static assert, or you can have constant expression. I mean, even if you don't do static assert, it's going to be the treated as a constant expression. So these are the outcome of the array computed through the evaluation as a constant expression. So to clarify it again, constant evaluation, const eval, is for if you want to guarantee that the function will never be called at runtime. It will be evaluated at compile time, but it will not be left for the runtime to call this function. Then you can use this keyword const eval. Okay, that is all I have to talk about this topic. Thank you for watching this recording.